Good morning, lecturer. My name is Kiwan Hong. I am from Group C002 and I have my group member Ang Ziyin, Mashi, and also Wendy. I'm going to give an introduction about our assignment. As the cybersecurity consulting team engaged by Malaysia Tech Solution, we are here today to present our risk assessment. MTS is a fast-growing tech company based in Kuala Lumpur, has expanded its services to include cloud-based solution clients in critical sectors such as finance and healthcare. The rapid growth has raised valid concern about the security of its evolving IT infrastructure, especially in the light of recent red flags, including unauthorized login attempts, irregular data access from overseas IP address, and the loss of employee device during travel. Our objective in this assessment is to evaluate the company overall security posture by identifying potential threat and vulnerability across four critical assets: the cloud infrastructure, which hosts sensitive client data and proprietary software. Second, the internal office network, which supports daily operations. Third, the customer web portal, which handles external client interaction. Lastly, employee endpoints, which involve both company issues and personal devices. Now, let's begin with the first critical asset, the cloud infrastructure. The first risk register is about unauthorized access. Risk: poor access control. Cloud environments frequently suffer from misconfigured permissions, overly permissive IAM roles, and missing multi-factor authentication. According to IBM's Cloud Threat Landscape Report 2024, nearly 40% of data breaches involve failure in cloud security, often tied to misconfigurations and weak access control. Third, unauthorized credential-based attack. The most common route for attackers is through stolen or compromised credentials. The 2025 Verizon Data Breaches Investigations report indicates that 22% of breaches started with credential abuse, and additionally 88% of basic web app breaches involve stolen credentials. Lastly, long-term data shows that around 31% of breaches over the past decades were driven by stolen credentials. The risk likelihood and the risk impact is high. Next, we will move on to the countermeasure. We can implement a zero-trust architecture with strong identity and access management, IAM, multi-factor authentication, and also network segmentation. First, enable MFA for all user and admins account in AWS and the local provider. Second, review and restrict IAM rules to enforce least privilege. Third, deploy cloud-native security tools such as AWS Guard Duty, Cloud Trial. Fourth, set up network segmentation using VPC and firewalls. Fifth, configure geofencing and anomaly-based alerts. 6. Train employees on secure device usage and data handling. 7. Establish a cloud security policy and conduct regular audits. The timeline is 3 months. The monitoring is through real-time SIEM and also monthly audits and 3 quarterly tests. The second risk register is about misconfigured cloud service. So the risk is human error and insecure defaults. A significant vulnerability in cloud environment is misconfiguration due to human error or insecure default settings, such as publicly accessible storage, open ports, and improperly scoped IAM policies. Trend Micros notes that 65 to 70% of cloud security incidents arise from misconfiguration, often as a result of rush declarations or lack of visibility. Furthermore, SentinelOne reports that 82% of cloud misconfiguration errors are due to human error, underscoring the prevalence of this issue in hybrid environment. The threat is about automated scanning and exploitation of misconfigured service. Threat actors routinely employ automated scanning tools to identify and exploit misconfigured cloud service, such as open storage buckets or unsecure APIs, leading to data exposure without needing to compromise credentials. According to the IBM X-Force Threat Intelligence Index, misconfiguration ranked among the top 3 initial access factor in cloud-related incidents in 2024, indicating significant risk in 2024. Strong DN confirms that cloud misconfiguration are responsible for 15% of all initial attack vectors, emphasizing the popularity of this method among attackers. So the risk likelihood is medium and the risk impact is high. Next, we'll move on to the countermeasure of this risk register. We'll implement an automated cloud security posture management framework and enforce IAC infrastructure as code to prevent, detect, and remediate cloud misconfiguration in real time across AWS and the local cloud provider. The implementation steps is: first, deploy a CSPM solution, for example AWS Config or Prisma Cloud. Second, define and apply hardened security baseline template. Third, enforce version control and change review process for infrastructure updates. Fourth, train DevOps teams on secure deployment practice and policy as code. Fifth, Schedule monthly audits and automated misconfiguration scans. 6. Remediate non-compliant resources using automation or manual intervention. The timeline is 2 months and ongoing monitoring. We will have a real-time misconfiguration alerts via CSPM dashboards. Next, we will move on to the third risk register, loss or theft. Risk, lack of device security control. A major weakness in MTS risk profile is the lack of robust protections, such as full disk encryption or remote wipe on employee devices that can access cloud system. Kensington's research indicates that 1 in 10 laptops will likely be stolen or lost from an organization over the lifetime of each computer, and 97% of stolen laptops are never recovered. Without encryption and remote wipe capabilities, these lost devices become high-value targets for attackers seeking cloud credential or sensitive data. Threats: unauthorized cloud access via stolen device. When an employee laptop or mobile device is lost or stolen, it can provide an attacker with a direct entry point to cloud accounts, especially if credentials, tokens, or sessions are left accessible. Verizon 2023 DBIR shows that lost and stolen assets is a significant attack pattern, frequently leading to data breaches through misuse of stolen credentials. This confirms the threat. Device theft can result in unauthorized cloud access and lateral movement within corporate systems. The risk likelihood is medium and the risk impact is high. Now let's move on to the countermeasure of this risk register. We can implement a secure endpoint device protection policy. So the implementation steps: first, enforce full disk encryption on all laptops. For example, BitLocker for Windows, Vault for Mac OS. Second, deploy MDM software, for example, Microsoft Intune or Jamf. Third, configure strong authentications, including biometrics or PIN plus password and cloud app re-authentications. Fourth, auto-log and inactivity timeout policy for all endpoints. Fifth, conduct staff training on secure travel and device practice. We will continue monitoring the MDM dashboard logs, incident tracking of reported lost or stolen devices. Next, we will move on to the fourth risk register, reliance on third-party cloud providers. Risk, limited control, vendor login, and shadow dependency. Reliance on third-party cloud providers reduce MTS visibility and control over infrastructure operation, as key responsibilities are managed by the vendors. Aqua Security highlights lack of visibility as one of the top risks in cloud computing, which arises when cloud service providers operate core systems beyond the customer's direct view. Additionally, vendors login creates dependency on proprietary features and formats, increasing the difficulty and cost of migrating to new providers. Threats: service disruption, regulatory breaches, and provider mismanagement. Third-party failures such as outage or policy non-compliance can disrupt MTS operation. Research into Microsoft 2024 outage underscores how redundancy and disaster recovery are essential to prevent significant business disruption. Concurrently, issues surrounding cross-border data storage and sovereignty heighten the risk of non-compliance with regulations like Malaysia, PDPA, and international standards. Next, we'll move on to the countermeasure. We can establish a cloud vendor risk management framework that includes multi-cloud redundancy, strong service level agreements, and also compliance reviews, and lastly, encryption standards. The implementation steps are as below. First, define and implement SLA for all cloud vendors. Second, deploy workloads across multi-regions or AWS and design fallback in alternate clouds. Third, encrypt sensitive data at rest and data in transit using organization-managed keys. Fourth, establish regular cloud vendors audits for compliance and performance. Fifth, document and exit transition strategy, including data portability, IAC templates, and also backups. The timeline is about 2 months, and we will continue monitoring the SLA violation, tracking, and incidents log. Lastly, we will talk about the last risk register, which is insecure API. Risk: weak API security control. Insecure APIs are among the most prominent threat to cloud security. The Cloud Security Alliance listed insecure interfaces and APIs as one of 11 major cloud vulnerabilities, stressing that improper or missing authentication, encryption, and validation can leave critical systems exposed. OWASP reinforces this, citing security misconfiguration such as improper HTTP headers or default setting as a key vulnerability in APIs. Threat exploitation via open or malicious API code. Attackers routinely scan and exploit unsecured API to access sensitive data or internal function. The OWASP API Top 10 highlights vulnerabilities like broken object authorization and broken authentications, which are actively being targeted. The risk likelihood and risk impact is high. Next, we'll move on to the countermeasure of this risk register. We can implement a secure API management framework that includes the use of API gateways, authentication standards, rate limiting, input validation, and regular vulnerability testing. The implementation steps are as below. Deploy an API gateway, such as AWS API Gateway, to manage all API calls. Second, enforce strong authentication and authorization, such as JWT. Third, apply input validation and schema enforcement on all API endpoints. Fourth, conduct automated security testing using tools like OWASP, XAMPP, or GroupC002. Fifth, enable logging, rate limiting, and anomaly detection at the gateway level. 6. Develop an API inventory and classification plan to track and manage all exposed endpoints. The timeline is 3 months. We will continue monitoring the logging via API gateway and also weekly review of API logs and alerts. Next, I will pass to Ziyin to talk about SS2, Internal Office Network. That's all from me. Thank you.
I'll be presenting 5 major cybersecurity risks identified in Malaysia Technology Solutions Internet Office Network, along with the countermeasures MTS is implementing to address them. The internal network supports daily operations from shared drive to back-end system. 5 high-priority risks were identified. Let's go through each risk and its planned mitigation. The first risk involves unauthorized access to internal servers. MTS currently lacks multi-factor authentication, the network is not segmented, and some internal systems remain unpatched. This creates opportunities for attackers to steal credentials and move laterally through the network. This will cause unauthorized access to sensitive systems, data exposure, and potential business disruption. To reduce this risk, MTS will implement MFA, segment the network using VLANs, and deploy intrusion detection system to monitor suspicious activity. This measure will block most unauthorized attempts and improve visibility across the network. The IT security officer will oversee implementation, which will be completed in 3 months and monitored monthly. Next is malware propagation. MTS allows overly permissive file sharing and lacks endpoint protection. Malware, such as ransomware, could easily spread between systems. This will cause mass infection, encrypted files, or even full system outages. To counter this, MTS will limit access to shared folders using least privilege, install endpoint detection and response software, and disable auto-mounting of network shares. These changes reduce the likelihood and speed of malware spread. The network engineer is responsible with a 2-month completion target and monthly monitoring. The third risk concerns insider data theft. Employees currently have broad access to internal files, user activity isn't logged, and USB devices are not restricted. This will cause confidential data to be taken out of MTS system, damaging compliance and trust. To address this, MTS will implement role-based access control, enable endpoint logging, and restrict USB access to encrypted devices only. These steps limit internal misuse and help detect improper behavior. The compliance officer will implement this within 2 months and with monthly reviews. Risk 4 targets the network infrastructure, routers and switches that use outdated firmware or weak admin credentials. Without hardening, attackers could intercept or disrupt traffic. This will cause downtime or unauthorized access to critical internal flows. MTS will fix this by applying firmware patches, configuring access control lists to limit traffic, and securing all admin interfaces. These upgrades will be managed by the network administrator and will be completed in 2 months, with monthly monitoring in place. The final risk is the exploitation of legacy systems still used at MTS. These systems are unsupported and unpatchable. Attackers could exploit non-vulnerabilities. This will cause breaches that are hard to detect and remove, threatening the entire internal environment. To mitigate this, MTS will isolate legacy systems in segmental VLANs, applying virtual patching, and develop a roadmap to fully replace them. These measures will reduce both the likelihood and impact of compromise. The IT project manager will lead this over 6 months with quarterly monitoring. Next, I will pass to Wendy talking about Asset 3, Customer Web Portal.
My name is Wendy, and I'll be assessing the risk for the third asset, which is the Customer Web Portal. MTS has a web application that allows clients to manage their accounts, access cloud services, and submit support requests. The fact that this portal is easily accessible by the public means that there are several potential risks. Firstly, weak passwords. With the prevalence of data breaches, more credentials are exposed to attackers, making it a challenge to create a secure password. By using exposed credentials, clients' accounts are vulnerable to brute force attacks, where the attacker uses trial and error to guess a user's credentials and gain unauthorized access to sensitive information. The overall severity of this risk is high, as the risk likelihood and risk impact are both high. To mitigate this risk, MTS can subscribe to an Exposed Credentials Database Application Programming Interface or API. By checking user passwords against the list of exposed credentials, MTS can notify users when their credentials are compromised and prompt them to reset their password as soon as possible. MTS should also provide some guidelines for creating secure passwords, for example, a minimum length of characters, and encouraging a combination of uppercase and lowercase letters, numbers, and special symbols. Subscribing to the API, integrating the API into the backend, and creating a notification system is estimated to take 3 months, and this process should be monitored monthly. Secondly, the lack of input sanitization. MTS's web portal does not sanitize its inputs, which means that it processes all user input as received. This makes MTS's web portal vulnerable to SQL injection, which is a risk with high likelihood and high impact. In an SQL injection attack, the attacker inputs malicious SQL code to gain unauthorized access to sensitive information or to perform destructive database operations such as drop or delete. To mitigate this risk, MTS developers should use prepared statements with parameterization feature to create a clear distinction between the SQL code and the data to be queried. It is estimated to take 4 months to update all the existing database queries and replace them with prepared statements. And this change should be monitored on a monthly basis to ensure that there is steady progress. Next, MTS's web portal currently does not limit the amount of requests that are sent to the system within a period of time. This makes it vulnerable to distributed denial of service or DDoS attack, where a system becomes unavailable after being bombarded by a large number of requests in a short period of time. The likelihood of this risk is classified as medium, because while DDoS attacks are common, they are not one of the main contributing factors of data breaches. However, this risk has a high impact because it's often combined with more powerful attacks to create more detrimental damage to an organization. MTS can transfer the risk to a third party by subscribing to a DDoS mitigation provider. Popular vendors such as Cloudflare, Radware, Imperva, and AWS provide effective rate-limiting services to avoid system downtime due to DDoS attacks. Researching and subscribing to an appropriate service provider is estimated to take 1 month, and the performance of the service provider should be monitored on a monthly basis to ensure that the subscription is effective in protecting MTS against DDoS attacks. Another vulnerability in MTS's web portal is Insecure Direct Object Reference or IDOR. This involves exposing internal object identifiers in the URL, which is dangerous as the URL can be seen by anyone who has visited the website, and it can be exploited to conduct a URL tampering attack. This involves modifying the object identifiers in the URL, for example, incrementing or decrementing a user ID to gain unauthorized access to confidential information. Due to the ease of identification and exploitation, IDOR attacks are categorized as high-risk likelihood and high-risk impact. To mitigate this risk, MTS should use indirect object reference maps to obscure the actual object identifiers used internally. First, indirect identifiers need to be generated for sensitive resources. Then, the direct identifiers in the URLs need to be replaced with the corresponding map values. This entire process is estimated to take around 3 months, and monitoring should be done monthly. Lastly, MTS's web portal uses HTTP or Hypertext Transfer Protocol. And HTTP is considered an insecure communication protocol due to the lack of encryption, which means that the data is being transmitted in plain text. This makes the web application vulnerable to man-in-the-middle attacks or MITM, which is when a malicious individual positions themselves between the client, which is the user, and the web server. After intercepting the data packets sent from the victim's browser, the attacker sends an unencrypted version of the web application to the victim, while maintaining a secure session with the actual web server. With the absence of encryption, it's easier for an attacker to conduct a successful man-in-the-middle attack. Due to the prevalence and potential damage caused by a man-in-the-middle attack, the risk is classified as high-risk likelihood and high-risk impact. To mitigate the risk, MTS should use secure communication protocols which utilize encryption to protect the data transmitted. MTS should obtain a TLS certificate and use HTTPS, which is a secure version of HTTP, for all communications. Moreover, MTS should ensure that they periodically renew their TLS certificate to maintain their status as a secure website. The initial process of obtaining a TLS certificate and implementing HTTPS is estimated to take approximately 2 months, and it should be monitored monthly. In conclusion, MTS's web portal has several vulnerabilities, including weak passwords, lack of input sanitization, lack of rate limiting, IDOR, and the use of insecure protocols. Addressing these vulnerabilities promptly can protect MTS's reputation and daily operations. Now I will pass to Mashi to assess the last asset.
Hello, my name is Nisrina Mashita. So today I'm going to talk about the assets 4, which is the employee endpoints. So for the first priority in this employee endpoints, which is the unsecure device and software. In this unsecure device, for the risk, which is the unsecure employee device risk access, malware, and data leaks, especially remotely. So then maybe can like exposes the passwords, name, or the any linked. And then the threat on this vulnerability, which is the malware infiltration via the unsecure device and software. So then for this severity, which is the risk likelihood and high, and then also the risk impact also high. How do we need to countermeasure in this vulnerability? We need to have the deploy EDR on employee device. How is the CANCB implementation? Deploy endpoint detection and responses, which is the EDR software across all employee laptops and desktop to make sure so all the things is secure in that device. So in this thing, we'll take the timeline which is in 2 months, and we need to monitoring monthly. For the next vulnerability, which is the weak authentication and access control. In this vulnerability, for the risk which is the weak authentication and the access control enable system breaches and the privilege abuse via the social engineering. So then other parties maybe can have a broken access into the admin panel, can be like access anything into the admin panel for the one of the company, anything. So then in this threat which is the unauthorized access via authentication and privilege misuse. So then of course in this risk likelihood high, and then also the risk impact also high. So then how is it going to be like countermeasure? In the we need to have the enforce multi-factor authentication MFA. How it can be like implementation is enforce MFA and all endpoints, cloud apps, and internal tools, which is like a Gmail accounts, which is like if like we have like access to one like laptop devices, and then we need to have authentication in another device which is on an handphone, and we need to authorize the things in through the linked authorized thing. So maybe it can make sure like something like that to make sure the countermeasure for not have any leaked data. So in this timeline which is 2 months, and monitoring is a monthly. So for the next part is plus secure VPN arbitrary file rates. For in this race is unpatched VPNs and with authentication allows attackers or to steal credential access sensitive files and move literally within the networks. So then how is it going to be work? Maybe we can like secure like pass the secure VPN, which is like access the phones, email devices, maybe can through the go through the Wi-Fi, which is any VPN networks. If it works, anything any other parties can steal our data. And then for this threat, which is the credential theft and unauthorized access via unpatched VPN vulnerabilities. So then for the risk likelihood, which is the high, and the risk impact is also the high. And then how is it going to be countermeasure? So then timely based on the VPN and remote access system. We need to immediately apply patch VPN release for all VPN and remote access system to make sure every data is very secure when we access to the VPN networks. And the timeline, which is 1 month, and monitoring we need to have a weekly. For the next vulnerability, which is the bring your own device BYOD risk. So in this risk is unmanaged personal device on the network risk, malware, data breaches, and credential theft. And in this trade is mitigating BYOD built parts inside like from the US Army, National Guard, the cyber attack, and also like hold the risk likelihood, which is the high, and the risk impact is also high. So then the countermeasure on this BYOD, which is we need to have a develop and enforce BYOD security policy for the in this implementation, which is the establish and enforce comprehensive BYOD, the security policies to ensures the personal and contractor device meet the company security standard before accesses the network. So then when the like bring our own device to make sure everything like have the security policy in that device to make sure to meet the company security standard before connecting to the network on the one company. So maybe like the timeline, which is 1 month, and we need to monitoring is weekly. So therefore the last vulnerability, which is Microsoft Office remote code execution via malicious document. So in this risk, maybe like can like users or any other parties create fake emails to make sure like office security in the documents enable malware installation on the devices and credential theft through the phishing. And then in this threat, which is a threat arising from the office document vulnerabilities and social engineering, and there is like hood, which is a high risk impact, also the high. And then for this countermeasure, which is apply regular office software patch and updates. How is it gonna do implementation? Regularly apply patch and updates to office software to fix vulnerabilities and protect against malware and credential theft developed via malicious documents. So then don't have any malware installation into the device or network, something like that on that company. So the timeline, which is the 6 month, and we need to monitor it quarterly. So that's all from me. Thank you.
Thank you, Mashi, for such a fascinating talk about SS4. So, to sum up, our risk assessment has really opened our eyes to the serious security challenge that MTS face today. We discovered that vulnerabilities like weak access control, misconfigurations, insecure APIs, and outdated systems could put the company's data and reputation at a great risk. But it's not all bad news. We also explore clear, practical solutions. By putting in place stronger access control, using secure coding practices, improving network segmentation, and keeping devices and systems up to date, MTS can significantly lower this risk. At the end of the day, cybersecurity isn't just about technology. It's about people, processes, and staying one step ahead of threats. By making cybersecurity a shared responsibility and continuously improving, MTS can build trust with its own customer and ensure smoother, safer operation moving forward. Thank you very much.